All right, so coming back from our donuts, we're gonna see that actually we're doing the same thing. But the whole idea here is that if I took a grid like this and I just wrapped it around really tightly so that each of these squares ended up directly on top of each other, I'd get one thing. I get sort of an identification of this point here with this point here with this point here with this point here. All of the middles of these squares would be identified. All of the bottom corners would be identified. All of sort of a third of the way across and 2/3 of the way up the square would be identified with a third of the way across and 2/3 of the way up this square, and so on and so forth. But what if instead of going that way, I decided to go this way? Now I could do the same thing and I'd have all of these ones identified. All of these squares would be identified. Well, what if I could do the same thing twice? What if I could wrap it this way and wrap it that way at the same time? Well, then you'd end up with a donut, and on each of your donuts, each of these squares would all be identified. So the middle of every one of these squares on this whole grid would be the same point. And if I went 1/3 of the way across one square and 2/3 of the way up, that would be identified with 1/3 of the way across any of these squares and 2/3 of the way up any of these squares, and so on and so forth. And now you could ask what would happen if I had a line. So here we see we've got a line that goes all the way up like that. Well, in this case, we're going to have this line is just going to be the same bit there, it's going to be the same bit there, it's going to be the same bit there, and they're all identified. Now, remember, we have a donut here. And so what's that going to mean? It's actually going to mean that the line starts at one point on the donut, and then it goes up and over as it's going around the donut until it comes all the way back up and meets at the same point again. And so it'll go over this sort of part of the donut once for every one time it goes around that sort of part of the donut. And so for instance, on the handout where we had y equals 3x on question 1, so what's that going to look like? Well, now we're going to go up and over 3 times before we come back around once that way. Okay, so there's sort of 2 circles going on here. There's a sort of a circle going around like that, and there's a circle going around like that. And so this first one is going to go the up and over circle 3 times as it just traces around this way once. And if we had y equals nx, then it's going to go up and over n times before going around once. And if we did it the other way around, we had a third, then that means it's going to go around that 3 times before it gets up and over once. And then P and Q would be around P times for going up over Q times. It's definitely worth asking your quicker students what would happen if P and Q shared a common factor. So for instance, if they were both even. Because if they were both even, well, going around 4 over 2 times is the same as going around 2 over 1 times, right? That slope is the same. It doesn't matter whether we call it 4 over 2 or whether we call it 2 over 1. And it's going to mean the same thing on our donut. Right, and that would work with any other factor that they might have in common. So we can sort of reduce the factors, otherwise we're just going to hit the same thing and we're going to double up again. That will tell you how many times you go up and over for how many times you have to go around in order to get back to the beginning again. And remember, getting back to the beginning sort of means crossing over one of the grid points up there. All right. Let your students wrestle with it. Let them work together in groups on this one. It's a great one to sort of bend your mind around. And don't be afraid if you feel like you've come off the racetrack, because the first time you see this, it feels like you're traveling too fast.